Stem cells are one of our body's basic building blocks. They have the potential to transform into any other type of cell that the body is built from. That's everything from individual blood cells to the complex cell structures that make up entire organs. Here at the University Medical Centre Utrecht, they are experimenting using stem cells in 3D bioprinting.
Building hydrogel strands bottom up, so layer by layer.
And one day hope to print replacement body parts. This printer works the same way as the ones we've seen in manufacturing. It deposits biological material layer by layer, but there are some significant differences.
When we look at printing metals or printing plastics, there's high temperatures involved, there's lasers involved, and there can even be organic solvents involved. And we have to extract that all out of the bioprinting process. So we have to redesign the whole process. And therefore we use an environment which is more like the human body, based on predominantly water, and at a temperature which is very close to body temperature.
We can see which cell is where.
Bioprinting uses a specially designed bioink, made of living cell mixtures. The cells are taken from patient biopsies or stem cells. A layer of water-based gel is printed between each layer of bioink.
We combine strong biomaterials, degradable plastics, that have been approved for medical use, and we integrate that in our printing process. And therefore you get like reinforced concrete.
One of the main challenges to bioprinting is creating vascular systems to supply blood to tissue. A focus now is on creating tissue-like structures to test toxicity of drugs or medical advancements without having to use people as guinea pigs. In the future, 3D bioprinted skin and replacements for damaged or diseased body parts may become reality. But right now, innovations in medical technology using traditional 3D printing continue. UMC Utrecht was also the first hospital in the world to implant a 3D printed skull. This operation happened earlier this year and the patient is recovering well. Another innovation from the University of Wollongong in Australia is this biopen, which allows surgeons to deliver live cells directly onto a patient's injury. Later this year, an experimental tissue lab is opening in Utrecht, and the university will offer the world's first joint degree program in biofabrication. It will teach technical skills, but also address ethical issues in this field.
You really need to bring in very good evidence and bring in things like research integrity. This is a very, to say so, fancy field everyone likes. But we need to be careful that we realize we are doing the correct steps and we are not overhyping something without the proper evidence.
We actually have the printer right here.
Back in a 2011 TED Talk, many people were impressed when Dr. Anthony Atala showed off the first 3D bioprinted kidney.
Here it is. You can actually see that kidney as it was printed earlier today.
But despite the showcase, this prototype kidney neither works nor can be implanted, and that's what researchers around the world are focused on, making bioprinted organs and limbs that surgeons can actually use.